Acrylic paints, polymerization and chemical reactions. Title: Acrylic paints, polymerization and chemical reactions. Introduction. Acrylic paints have revolutionized the art world, offering artists an array of vibrant colors and versatile applications. These paints are made up of a synthetic polymer emulsion, creating a paint medium that is water-soluble, fast-drying, and flexible. Understanding acrylic polymerization. Polymerization refers to the process of linking smaller molecules, called monomers, to form larger chains known as polymers. In the case of acrylic paints, the monomer is usually methyl methacrylate. MMA. MMA undergoes free radical polymerization, which occurs when the monomers react with initiators, such as benzoyl peroxide or ammonium persulfate, in the presence of heat or light. This initiates a chain reaction in which monomers combine and form long chains, creating a three-dimensional network structure. Chemical reactions. Several chemical reactions occur during the polymerization process of acrylic paints. Let's explore some key reactions involved. 1. Initiation. During the initiation stage, the initiator molecules decompose under heat or light, resulting in the formation of free radicals. These highly reactive species have unpaired electrons and are highly capable of initiating the subsequent reactions. 2. Propagation. Once the initiation stage occurs, the created free radicals react with MMA monomers, causing the chain reaction to propagate. The free radicals attack the carbon-carbon double bond in MMA, breaking I T and forming a new bond with the carbon atoms, resulting in a continuous chain growth. This process repeats until most of the monomers have reacted, leading to the formation of a large polymer network. RK. 3. Termination. Termination reactions occur when two free radicals combine, terminating the chain reaction. The termination reactions help control the length of the polymer chains and the overall molecular weight of the acrylic paints. Properties of acrylic paints. The polymerization and chemical reactions involved in acrylic paints contribute to their unique properties, making them popular among artists. Let's explore some of these properties. 1. Fast drying. Acrylic paints dry rapidly compared to oil paints. The polymerization process and the water-based nature of acrylics allow them to evaporate quickly, enabling artists to layer colors and work efficiently. 2. Water-soluble. Acrylic paints are water-soluble, making them easy to thin and clean up with water. Artists can control the paint's consistency, from thick and buttery to transparent washes, by adding water or medium. This versatility allows for various techniques and effects. 3. Flexibility. The polymer network formed during acrylic polymerization provides flexibility to the paint film. This flexibility allows the paint to expand and contract with temperature and humidity variations, reducing the risk of cracking or peeling over time. 4. Longevity and stability. Acrylic paints are known for their long-term stability. The polymerized structure enhances their resistance to light, heat, and chemical degradation, resulting in paintings that can withstand the tests. T of time. In recent years, there have been numerous advancements in acrylic paint technology, further expanding the possibilities for artists. One such advancement is the development of acrylic mediums and additives that allow artists to modify the properties of acrylic paints. These mediums can enhance the transparency, viscosity, and drying time of acrylic paints, offering artists even more versatility and control over their artistic process. Additionally, artists can also experiment with various techniques, such as pouring, glazing, and impasto, to create unique textures and effects. The fast-drying nature of acrylic paints allows for layering and building up of colors, making them ideal for creating rich and vibrant artworks. Furthermore, the longevity and stability of acrylic paints make them a preferred choice for professional artists and conservators. Once the paint has fully dried and cured, it forms a durable film that can withstand environmental factors and resist fading. This makes acrylic paintings suitable for display in various settings, including galleries and museums. The versatility and vibrant colors of acrylic paints have revolutionized the art world. These paints are made from a synthetic polymer emulsion, making them water-soluble and fast-drying. Understanding the process of polymerization and chemical reactions behind acrylic paints can provide valuable insights into their properties and allow artists to make informed choices. Polymerization is the process of linking smaller molecules, called monomers, to form larger chains known as polymers. In the case of acrylic paints, the monomer is usually methyl methacrylate, MMA. MMA undergoes free radical polymerization, which occurs when the monomers react with initiators in the presence of heat or light. This initiates a chain reaction in which monomers combine and form low chains, creating a three-dimensional network structure. Several chemical reactions occur during the polymerization process of acrylic paints. The initiation stage involves the decomposition of initiator molecules under heat or light, resulting in the formation of free radicals. These highly reactive species have unpaired electrons and initiate subsequent reactions. During the propagation stage, the free radicals react with MMA monomers, causing a chain reaction to propagate. The free radicals attack the carbon-carbon double bond in MMA, breaking it and forming a new bond with the carbon atoms. This process repeats until most of the monomers have reacted, forming a large polymer network. Termination reactions occur when two free radicals combine, terminating the chain reaction. The termination reactions help control the length of the polymer chains and the overall molecular weight of the acrylic paints. The polymerization and chemical reactions involved in acrylic paints contribute to their unique properties. Firstly, acrylic paints dry rapidly compared to oil paints due to the polymerization process and the water-based nature of acrylics, allowing artists to layer colors and work efficiently. They are also water-soluble, making them easy to thin and clean up with water. Artists can control the paint's consistency by adding water or medium, allowing for various techniques and effects. Additionally, acrylic paints are known for their long-term stability. The polymerized structure enhances their resistance to light, heat, and chemical degradation, resulting in paintings that can withstand stand the test of time. Continuous advancements in acrylic paint technology have expanded the possibilities for artists. Acrylic mediums and additives can modify the properties of acrylic paints, enhancing transparency, viscosity, and drying time. Artists can also experiment with techniques such as pouring, glazing, and impasto to create unique textures and effects. The durability and resistance of acrylic paints make